Launch Director.
Launch vehicle is ready to launch.
Mission Director.
3,
You have permission
2.
to launch.
We have ignition of the RS-68A main engine. And we have liftoff of the United Launch Alliance Delta IV Heavy rocket.
Mach 1, execute, and we have indication of spacecraft separation.
Good afternoon. I'm Andrea Lenhop. I'm a systems engineering leader at ULA and your host for today's live broadcast of the final Delta Heavy carrying NROL-70 for the National Reconnaissance Office. I'm here at Cape Canaveral Space Force Station in Florida, where liftoff is currently scheduled for 2:45 p.m. Eastern. In addition to watching our webcast, you can also follow live mission progress at ulalaunch.com. The count is currently in a planned hold. We have 2 planned holds in our launch count, which give our team time to resolve any issues prior to entering the terminal count. At this time, the team is not working any issues and we're proceeding towards an on-time liftoff. Live mission coverage will continue through payload fairing jettison, which occurs approximately 6.5 minutes after liftoff. To tell us more about today's mission customer, let's go to ULA's Ben Chilton over at the Friends and Family Viewing Area on the NASA Causeway.
Thanks, Andrea. I'm Ben Chilton, an ordnance engineer at ULA, and I'm joining you from the NASA Causeway, just a few miles south of Space Launch Complex 37. Today's launch is for the National Reconnaissance Office, or NRO. The NRO is the leader in developing, acquiring, launching, and operating the nation's intelligence, surveillance, and reconnaissance satellites to secure and expand America's advantage in space. The NROL-70 mission will strengthen the NRO's ability to provide a wide range of timely intelligence information to national decision makers, warfighters, and intelligence analysts to protect the nation's vital interests and support humanitarian efforts worldwide. Back to you, Andrea.
This is the 16th and final flight of the Delta IV Heavy rocket and ULA's 160th launch. Here's more about this heavy lift rocket.
Designed by ULA's engineering team and built by our skilled technicians, the Delta IV Heavy rocket, once fully stacked, stands 235 feet and weighs 1.6 million pounds fully fueled. At the base of the rocket is the triple booster first stage, powered by 3 RS-68A engines, which together produce more than 2 million pounds of thrust at liftoff. Atop the center booster is the Delta Cryogenic Second Stage, or DCSS, powered by an RL-10 B2 engine. Spacecraft are encapsulated inside a 5-meter diameter metallic tri-sector payload fairing. With production of the final Delta complete, the rocket travels from ULA's factory in Alabama to the launch site in Cape Canaveral on ULA's rocket ship. Once in Florida, ULA's launch operations team begins a series of events leading to today's countdown. The process begins by transporting and lifting the booster and DCSS onto the launch table at Space Launch Complex 37. Then, the encapsulated payload fairing is lifted and mated to the DCSS. Once fully assembled, the launch countdown begins when 40 hydraulic cylinders at pressures nearing 3,500 psi raise the Mobile Service Tower, or MST, about 8 inches. The carriage transporter system then moves the MST to its launch position, approximately 345 feet north of the rocket. Weighing in at approximately 10 million pounds, the 100-foot wide, 300-foot tall MST protects the rocket and payload from weather here on Florida's Space Coast. With the rocket on the pad, the launch team transitions to fueling and other final preparations. Across the interstage of the Delta IV Heavy rocket is the American flag and the Space Force, Delta, and ULA logos. Note the number 389 inside the Delta logo, signifying this launch's place in Delta history. Additionally, on the fixed umbilical tower, we see mission artwork. Provided by the NRO, the art features a snow leopard, representing the NRO's quiet strength and providing an advantage to community, the nation, and its allies.
Today's flight is dedicated in memory of colleagues who are no longer with us. Let's remember our teammates.
Today's flight is dedicated to Doug Thompson, Mark Cox, Brent Bonar, and George Lucian. After working as a pipe fitter for high-purity systems, Doug Thompson joined Boeing's internal upper stage program, later transitioning to the Delta program. Doug supported many Delta rockets and facilities during his career, including Delta vehicles launching from the Cape's Slick 17 and Slick 37 and Vandenberg's Slick 6, in addition to solid rocket booster and payload facilities and the machine shop. In his personal time, Doug and family traveled throughout Florida and Georgia, enjoying his passion for motorsports, including drag racing the '63 Corvette he built himself. He will be missed. As a U.S. Army veteran, Mark Cox began his aerospace career in 1984 at McDonnell Douglas, then Boeing, and eventually ULA. Following his transfer from ULA's Pueblo site to the Decatur, Alabama factory, Mark was instrumental in establishing the metrology lab there and in standardizing measurement and test equipment calibration across all ULA sites. He was respected by his peers throughout the industry and developed many personal relationships over the years. Always resilient and positive, Mark encouraged his teammates to face adversity while continuing to care for others. He will be greatly missed. Godspeed, Sergeant Cox. Brent Bonar joined Aerojet Rocketdyne as a space propulsion mechanic in 2006 and contributed to the safe delivery of nearly every RL-10 engine through his last mission, NROL-68, in 2023. A loving husband, Brent was also a tireless volunteer, deeply committed to helping others, including 3 trips to the Bahamas in 2019 to support residents following Hurricane Dorian. This effort led Mark to logging more than 600 volunteer hours and being recognized as Aerojet Rocketdyne's 2019 Volunteer of the Year. Brent was kind and generous and a role model to many people. He will be missed. George Lucian began his career in 1960 as an electrical systems engineer with the General Dynamics Corporation, following his time at the University of Nebraska, where he earned a bachelor's degree in mathematics. In 1964, after working at the General Electric Company on the Apollo program, George began a new chapter at the Goddard Space Flight Center, followed by a move to the Kennedy Space Center. During his NASA career, George was an engineer, branch chief, division chief, and assistant launch manager, all in support of NASA's Expendable Launch Vehicle Services program. His career spanned 60 years and more than 400 launches. George was an invaluable team member, a mentor to many, and a true friend to all.
Form CBC box foundry and valve cycle test.
Roger.
Minus 21 minutes.
Field 2, perform second stage LH2 foundry and valve cycle test.
Roger.
LOX 2, perform second stage LOX foundry and valve cycle test.
Roger.
Since 1960, Delta rockets have been an integral part of America's space program. The on-orbit assets it has launched have improved life across the globe. Let's take a look.
Following more than 60 years lifting historic missions to space and becoming a pillar in American rocketry, the Delta program is coming to a close with its final launch. Here's a look back at some of the groundbreaking firsts and iconic missions launched on Delta rockets. Delta quickly established its record of excellence in the 1960s, launching ECHO, the world's first communication satellite, Tyros, the first space-based weather observatory, and NASA's Pioneer and Explorer scientific spacecraft. The introduction of the Delta II rocket on Valentine's Day 1989 ushered in the GPS era, and a capability that improves life on Earth every day, from navigation to banking, agriculture, and beyond. The beloved Delta II earned its place in history with 155 flights, with 8 of those missions to Mars for NASA, including the Spirit and Opportunity rovers. The Delta program's commitment to vehicle improvement to meet customer needs culminated in the Delta IV family of launch vehicles, with with a wide range of increased capabilities. Delivering missions for the Space Force, National Reconnaissance Office, NASA, and commercial clients, every Delta IV launch has been successful. As America's trusted heavy lifter, the triple-barreled Delta IV Heavy launched the first Orion spacecraft on an uncrewed shakedown cruise and sent the Parker Solar Probe to surf the atmosphere of the Sun. The 16th and final flight of the Delta IV Heavy rocket carries NROL-70, capping off the incredible legacy of this program.
The Delta program has been an important part of many of our employees' careers. We recently spoke with employees about what the Delta rocket has meant to them.
We started this program with the tremendous task of continuing the Delta mission success tradition.
It has been the heavy lift workhorse, supporting the missions that no other vehicle could, and have made a tremendous difference for this nation.
The assets that we launch with Delta are crucial to our warfighter and have really allowed us to sustain our capability not only in space, but also just on the ground and keeping the entire world in a better place.
That ability to impact the nation in what we can do, our technologies, as well as our reach into space. It's just an honor. There's no other way to say it.
Look at what we as part of the team have done to improve life on Earth. All things to be extremely proud of.
The first launch, you kind of kept your fingers crossed and your toes crossed. We all stood out in the main part of the factory here and watched it, and it's just something that you do and say whatever makes you comfortable for that very first launch.
Watching the Delta IV Heavy right outside the door of the Delta Operations Center and feeling the vibration and just amazement.
I was at the launch site in the dock for the NROL-70 mission, and the experience when that thing lifted off of the acoustics, hitting that facility and literally seeing the windows flexing from the acoustics of that liftoff was something I will never forget.
I've been down to the launch site, been on the pad, been on cranes up and down a heavy vehicle, been able to support on console, and been part of the day of launch activities. So I've seen it from a unique perspective. Those memories will always stick out.
We took a lot of lessons from Delta. Aluminum skins, machined, brake formed, welded together with friction stir welding. The first time we used that was on the Delta IV program.
One lesson learned from Delta IV that will stick for our future launches is our record of mission success and our focus on mission success, making sure that all of our launches accomplished what we wanted and delivered the payload for our customers.
The teamwork that we built across all the different suppliers and across the program itself. It's a really complex vehicle, and so being able to bring that whole team together and deliver Delta for that many years has been brought over into the Vulcan program and will continue to live on.
Whether it be in the design center, the operations center, the production center, we're all a big team, and those teams work together, and it's magic.
Launch conductor is only one little cog in the whole process. This is a team sport, and the team has done nothing but a phenomenal job.
Taking pride in your work and treating everything as if it's the most important job you'll ever do is something that I will keep with me for the rest of my career.
Well, it's bittersweet, of course. We all thought we could do this a lot longer because we love it so much.
It's been a wonderful rocket to work on over these years, and I'm going to miss it.
It is the most amazing rocket I could ever imagine, this Delta IV Heavy.
I'm just proud to have been a part of this team and was able to better my career by working alongside an amazing team.
The legacy of Delta will live on in the Vulcan rocket and in the people that make it a reality and have taken the best of what Delta has accomplished and carry that forward into the future.
L minus 14 minutes.
As gas, establish scan pattern 140. Roger. VSE, verify base bending moment, instrumentation is active and data is valid.
BBM is fully mission capable. Recommend placard 6 alpha for launch.
Roger. OS, set BBM active.
Roger.
With this launch, we are also remembering an NRO teammate. Here is Mission Director, Colonel Eric Zaribaninski.
This is the MD. This afternoon's NROL-70 launch is dedicated to the memory of Colonel Edward Chip Zakrzewski. Chip dedicated his career to the advancement of space launch and to the success of NRO missions. He was a fierce advocate and leader for the Office of Space Launch and in the broader space launch community. Chip was the OSL director for the first Delta IV Heavy launch, so it is only fitting that the last Delta IV Heavy launch is dedicated to him. To our leader, mentor, and friend, Godspeed, Chip. MD out.
L minus 12 minutes.
MEQ, initiate retract data logger just prior to the L7 pole. Roger.
After liftoff, the Delta IV Heavy will head east from Space Launch Complex 37. Here's a look at today's ascent.
To mitigate the fireball created by the hydrogen-burning Delta IV Heavy rocket, the staggered engine start sequence begins with ignition of the launch table HBOs, burning off the excess hydrogen injected into the flame duct. Next, the starboard Delta IV Rofi lights, igniting its RS-68A engine. Then, the center and port RS-68A engines ignite to generate more than 2.1 million pounds of total thrust to lift the 1.6 million pound triple-core rocket off the pad. Shortly after liftoff, Delta begins a pitchover to attain the proper flight path while minimizing the pressure the vehicle experiences during flight. Delta then reaches Mach 1, the speed of sound, followed by the rocket reaching maximum dynamic pressure as it travels through Earth's atmosphere. With propellant depleted in the port and starboard boosters, the engines shut down and the boosters jettisoned to shed their weight. The remaining booster engine then throttles to full power to maximize performance against gravity losses. Once propellant levels deplete in the center booster, the engine shuts down and the booster is jettisoned from the second stage. The vehicle now weighs approximately 6% of what it did at liftoff. Following jettison of the center booster, the Delta Cryogenic Second Stage, or DCSS, main engine ignites. During ascent, NROL-70 is protected inside a 5-meter diameter metallic payload fairing. After traveling through the densest part of Earth's atmosphere, the payload fairing is jettisoned. The Delta IV Cryogenic Second Stage carries the last payload to launch on a Delta IV rocket to its final orbital destination, where it will begin its national security mission.
As we can continue the countdown to launch, let's head over to Ben Chilton on the NASA Causeway.
Of ULA friends and family excited to witness the last liftoff of this magnificent rocket. I'm approximately 3 miles from Slick 37, and when we reach T0, it will take about 15 seconds for the sound to reach us, though we'll already have seen Delta lift off the pad. From where I'm standing, it's a little windy at the moment, but I'll pass it off to Space Launch Delta 45 Weather Officer Arlena Moses for today's weather forecast.
Thanks, Ben. As you mentioned, it is a little breezy out there this afternoon, and that's going to be our main weather watch item for our launch today. If you were out earlier, you did notice that we had some showers kind of pushed through about an hour or so ago. Those are well to the south. Don't expect any more showers or concerns with that. So our main concern will be our breezy conditions coming from the northwest as we see behind kind of the showers in front that pushed through earlier. Currently across the area, we're seeing gusts into the 20s. And if we look at the forecast going forward to our current T0 today, we are looking at a probability of seeing weather violations of 70%, with our main concern being those ground winds, as we can see here with some of our gusts across the area. But we are looking at sustained winds ticking up just a bit here over the next few minutes, kind of coming up into that 20 to 30 knot range. So continuing out of the northwest, temperature is about 72 degrees, and hopefully we'll be able to keep those winds down just enough that we'll be able to see the launch of our Delta IV Heavy this afternoon. Back to you, Andrea.
We remain in the planned hold as we continue towards liftoff. In a few moments, launch conductor Scott Barney will pull the launch team for the final go to pick up the count. 28 engineers and managers are pulled for system status and readiness to proceed. This is the final status check for all Delta vehicle systems, ground systems, spacecraft, and the U.S. Space Force Eastern Range. The vehicle system readiness pull includes electrical systems, hydraulics, pneumatics, propulsion systems, and flight control, and propellants. Let's listen in as Scott Barney performs the final pulling.
Minus 7 minutes.
Status check to proceed with terminal count. First stage systems, propulsion.
Go.
Hydraulics.
Go.
Locks.
Go.
LH2.
Go.
Second stage system, locks.
Go.
LH2.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
GCQ.
Go.
Operation support.
Go.
Pneumatics.
Go.
Umbilicals.
Go.
HAZGAS.
Go.
ECS.
Go.
Radar monitor.
Go.
Mechanical engineering.
Go.
Quality.
Go.
Op safety manager.
Go.
UA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. ALC. Verify T0 is set for 18:45:000.
Verified.
MEQ. Establish swing arm lock pins. Pull.
Active.
Pulling is complete and the team is go for launch. From T-minus 4 minutes until liftoff, you'll hear Scott Barney and the team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank levels and pressures in the 3 boosters and the DCSS, in addition to arming the flight termination system. At T-minus 1 minute, the Range Operations Commander confirms the range is in a green condition for launch. At T-minus 15 seconds, the launch table HBOs at the base of the rocket are ignited to burn off excess hydrogen. At T-minus 7 seconds, the starboard engine is ignited. At T-minus 5 seconds, the port and center engines are ignited. Once the Delta IV Heavy lifts off, you'll hear flight commentator Rob Gannon providing launch vehicle ascent data. This is Delta Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
T-minus 4 minutes and counting.
Hold, hold, hold. This is flight control. We have a CCLS red line fault at T-minus 3 minutes and 58 seconds.
LC switch not ready. All personnel go to recycle steps for operation 90. Okay, LC switch is not ready.
Flight control is ready to set clock to T-minus 4 and holding.
Roger. ALC, reset countdown clock to T-minus 4 minutes and holding.
Roger. LC flight control, SS BAP inactive and SCS in pre-flight mode.
Roger. And prop lead, evaluate locks, recycle, and report if ready to recycle.
4800. Roger. Red line that we've...
OSM, place the SRM ignition switch to disable position.
SRM ignition disabled.
ALC, count. Disregard.
LC countdown clock has been reset to T-minus 4 and holding.
Roger. For step 90, all stations recycle systems back, T-minus 4 holding in configuration. Recycle occurred at T-minus 3 minutes, 58 seconds. Report status at completion.
LC fuel 1.
Go fuel 1.
Substep golf. CBC LH2 inerting is active. Excuse me. LH2 conditioning is active.
Roger.
LC FTS.
Go.
Substat Juliet, FTS safe and external.
Roger.
LC locks 2.
Go.
Second stage LO2 conditioning active.
Roger.
LC locks 1.
Go.
CBC locks conditioning active.
Roger.
LC ECS.
Go.
ECS set point stable.
Roger.
LC fuel 2.
Go.
Second stage LH2 conditioning active.
Roger.
LC SYS.
Go.
GC3 ready.
Roger.
LC has gas.
Go.
Step Foxtrot has gas ready. And as MEQ, should I reinstall lock pins?
Yes, let's install pins.
Roger.
LC AB.
Go.
For substep Papa, vehicle external.
Roger.
LC prep 101.
Go.
All systems are stable.
Roger.
LC flight control.
Go flight control.
Step 180, substep kilo, flight control ready.
Roger.
LC MEQ.
Go.
Substep Oscar, TSM and swing arm systems ready.
Roger.
And substep alpha, pneumatic pressures stable.
Roger.
LC HOE.
Go.
Hydraulic system stable.
Roger.
This is Delta Mission Control at T-minus 4 minutes and holding. The planned hold has been extended. We will pass on more information as it becomes available.
Detanking. And LD, just to confirm, we're in a scrub declaration for 24-hour turnaround.
Stand by for that.
Roger. GELC.
G.
Verify TISR status for India.
Just ready.
Roger. All right, team, we've given direction recycle is now complete. We get direction to proceed into detanking. Okay, for the team, we'll be or standby.
This is Delta Mission Control. It's confirmed that we will not continue with the NROL-70 launch activities today. We have a 24-hour recycle. Our next launch attempt will be tomorrow at 1:37 p.m. Eastern. For up-to-date information, please visit ulalaunch.com. I'm Andrea Lenhoff. Thanks for joining us.